We're going to look at sequences in this unit. The first one we're going to look at is an arithmetic sequence. We want you to be able to find out something called the common difference, which we'll talk about, and also what the nth term of one of these arithmetic sequences is. Okay, so a sequence. A sequence is a list of numbers in a particular order. We label the terms of a sequence like this: A1, A2, A3, etc. This would be the first term. A2 would be the second term, etc. all the way. A sub n we call the nth term, and it also means it's the last term in the sequence. Okay, so n would be the number of terms in this one. And the sequence is basically like a pattern. There's some kind of pattern going on that moves you from one to the next. One famous pattern or sequence is the Fibonacci sequence. The pattern to this is a little bit harder to see than some of them we're going to be looking at. But the pattern here is that if you add the previous two numbers, you get the following number. So like here, if you add 1 plus 1, it equals 2, which is the next number in the sequence. If we take the next two now and add these together, 1 plus 2, we get the next number, 3. And that continues all the way through this. If you add 2 plus 3, you get 5. If you add 3 and 5, you get 8. And it just kind of keeps repeating. So that's an example of a sequence. The one we're going to be focusing in on today is what's called an arithmetic sequence. That's a sequence in which each term after the first term is found by adding a constant called the common difference. So if you look at this example here, studying the pattern, it looks like every time to get from one number to the next, you're adding 2. That means the common difference, and we're going to use D for that, is 2. On the next notes, we're going to look at another one called a geometric sequence. This is a sequence in which each term after the first term is found by multiplying the previous term by a constant called the common ratio. So if you look at this next one, it looks like the pattern here is multiplying by 2 or timesing by 2 each time. Okay, so there we would say the common ratio, which we use R, is 2. All right, so we're going to focus in today on the arithmetic ones. And in this first one, they want us to find the next couple terms in the sequence given the ones we got. So your first, or your challenge is to figure out what is this common difference. What's taking us from one term to the next? Well, here it looks like it's going down, so it must be a negative number. Looks like we're subtracting 6 each time. So if we keep subtracting 6, the next term would be 37. Subtract 6 again, you get 31, 25, and 19. Okay. Next problem. What is the common difference of this sequence? So what's the pattern here? Well, looking at it, it looks like we're adding 7 each time to go from one term to the next. So here the common difference would be 7. Now, if it's hard for you to see, you can always get the common difference by taking a term minus the one before it. So on this one, we could get that same thing by taking 6 minus the term before it, which is -1. Well, if we minus a negative, that's the same as plus, and you do get the same thing as 7. So that's another way you can find it if you're unsure. Let's look at a kind of sequence term where you can find the nth term or the last term. So if you're given some information about an arithmetic sequence, you can find any term using this formula. This is the nth or last term, or the term you're looking for. This we've talked about already. That's your first term. N is the number of terms. And D would be the difference. Okay, so this formula can be used to find out answers on problems. Let's look at number 3 here. It says the table on the right shows the cost for a construction company to rent a crane for 1, 2, 3, or 4 months. If the sequence continues, how much would it cost to rent the crane for 12 months? Okay, so we want to find some stuff out here. What do we know? Well, here's our terms. Our first term here is 75,000, second term, and so on. They want us to find at 12 months, which means here n is going to be 12. Okay, so we got some important information. We know that a sub 1 is going to be 75,000. We know n is 12. One more thing we can figure out looking at the pattern over here of our sequence is that d is going to be the common difference here. If we subtract the second and first one, we get 15,000. So it looks like the common difference, every time you go from one term to the next, it's adding another 15,000 on. So this formula over here should take us to the answer. If we want to find how many it is after 12 months, take the first term, 75,000, plus n, which is 12, minus 1 here, times the common difference of 15,000. So if we solve this, it should take it to the number we want. So taking 12 minus 1, that's 11 times 15,000. Now let's use our calculator here and see what the solution is. So if we do 75,000 plus 11 times 15,000 should give us our solution of 240,000. So that's one way you can do this. Now, that equation works great. If you want to use it, go for it. Absolutely, it'll work every time. But if you're kind of one of those people who have a hard time just kind of remembering formulas, there is another way we can do this one. So another way we can remember or go back to doing these is to use slope-intercept form, which is very close to what we're doing here. In slope-intercept form, your repeated slope, or the thing that keeps being added every time, m, is basically the same thing as d, our common difference here. X is the number of times you're going to do that slope. So x is like n. Okay. Y would be how many times you're going to end up doing it. That's like a sub n. And then the only difference is b. B is your y-intercept, what it is at 0. In this equation, it's what it is at 1. So if you're going to do it this way with slope-intercept form, you kind of have to figure out what would be the term before the first term. What would a sub 0 be? Okay, and slope-intercept will give you the same answer to the prop. So let's go back and look at this last one and do the same thing, but with slope-intercept form. So if we were going to do it here, our common difference, d, would be the same as our slope, m, and that would be still 15,000. Our x would be like n in this problem. We're doing 12 months, so x would be 12. And then the other thing we would want to know is what is the starting amount? What's a sub 0? Okay, so if you look at our pattern here, it would be, what was the term just before this one? What would a sub 0 be? Well, if we went back, we would want to take 75,000, what a sub 1 is, and just subtract the common difference of 15,000. And that would tell us our a sub 0 is going to be 60,000. So if we use slope-intercept form, we should get the same thing. Y equals mx plus b. Here, our slope, or our difference each time, is 15,000. We're doing it 12 times, and the 0 amount would be 60,000. And if you put that in the calculator, it should give us the exact same answer, 15,000 times 12 plus 60,000, and we should get the exact same answer here of 240,000. So that's another way. If you don't want to remember another formula, you get the same answer with a formula you've already learned, slope-intercept form. So you can definitely use slope-intercept form on these two. All right, number 4, write the equation for the nth term of this arithmetic sequence. So what they tell us here is the pattern starting with 8, 17, 26, and 35. This looks like a problem we've done already. We can easily find some stuff out here. It looks like the common difference each time is adding 9. So 9 is our D. Another thing we know is 8. That's our first term. So base of 1 would be 8. One other thing that we, or then to solve this one, we would take that information and use it to do it. So you could either use this equation up here, or just stick with our slope-intercept form. Okay, so if you do slope-intercept form, it's y equals mx plus b. We would want to know though what is b? What's the a0 going to be? So a sub 0 would be, what if we went back one more? What if we took 8 and subtracted 9 from it? Well, that would be negative 1. So this is our m, this would be our b, and x in this case would just be like our n. So our equation would be like d times n plus a sub 0. So now I just put in the information and we got our equation here. Instead of y, I suppose we should write a sub n. So a sub n would be our difference of 9. We don't know what n is. They just want an equation that has n in it. Plus negative 1. Or that a sub n would be 9n minus 1. And that equation, if you put any n in there, you could find the term that you're looking for in that sequence. This equation up here will work too, so just to show you that this one also works, let's try that one. For those of you who like that sequence, or this formula. So a sub n would be the first term, 8, plus n we don't know, so you keep it as n minus 1 here, and then d is 9, common difference is 9. If you solve this one, it should simplify to the exact same thing. Got distribute, and then if we combine like terms here, we get the same thing of 9n minus 1. So either way works. You choose the one you like best. All right, number 5, we'll find the 42nd term of this sequence. So this is kind of like we did on the last one. Now we're going to use it to find out what that term is later on. So I'm going to use the kind of the y equals mx plus b way. So a sub n equals our slope. Well, our slope here, or our change is, looks like plus 7. So 7. We want to find the 42nd term, so we're going to do 7 42 times. Plus, what's our a sub 0? What would this be if we went back 7? Well, if we went back 7, a sub 0 would equal 1, because 8 minus 7 is 1. So now if we solve this, 7 times 42 is going to be 294 plus 1. So a sub 42, the 42nd term here is going to be 295. If you want, that should give you the exact same answer. Let's try another one here. Number 6, given that the first term is 13 and the common difference is negative 2, find the 11th term. Okay, we see 11 there. That means they want us to find the 11th term. Okay, so we know our common difference here is negative 2. A sub 1 is 13. That means a sub 0 would be our first term minus our common difference here of negative 2. So it looks like our 0 term would be 15. And then n is going to be 11, since we want to find the 11th term. So if we do our y equals mx plus b, or a sub n equals dn plus a sub 0, we can find that. So our 11th term is going to be our difference, negative 2. N, the number of terms we're going to do is 11 plus a sub 0 would be 15. So negative 22 plus 15, or negative 7. Negative 7 would be the 11th term in this sequence. All right, number 7 says Farmer Rupert starts the hay season with 37 alfalfa bales in his barn. Each day he adds 40 alfalfa bales to the barn. Part A says, how many bales will he have in the barn at the end of the month? Well, let's see what we know on this problem now. We got, starts with 37. That's telling us that if he's starting with that, that's not even after 1 day. That would be our a sub 0 is 37. Each day he adds 40. That's saying our difference here is 40. How many bales will he have in the barn at the end of the month? Okay, well, at the end of the month here, that, well, I think on your note sheet it says that it's a 30-day month. That means N is 30. Or another way of thinking about it, if this is slope-intercept, that's our B. D, our difference, what we're changing each time, that's like our slope. And then this would be our X. So we can find this out using slope-intercept form. This would be 40 times 30 plus where we started at 37. And if you calculate that out, looks like there'd be 1,237 bales at the end of the month. All right, let's look at part B. Part B says, how many days would it take Farmer Hooper to have a total of this many bales in the barn? Well, using the information we have already, we should be able to solve that. This would be, if we go with like our y equals mx plus b again, this is what we want to end with. That's going to go in for y. So you got 17,570, or 57, I'm sorry. Each month, again, remember that it was, or every day was going up by 40. We don't know how many times, but we know the starting amount was 37. If we solve this for x now, that'll tell us how many days. So here it looks like you got a minus 37. And then divide by 40. And we would know the number of days. Looks like the number of days comes out to be 43 days. So it'd take 43 days to get that many. All right. Why don't you try some of these out on your own now, either using that sequence formula or slope-intercept.